All right, let's dive into something really cool today, a Python library called Pytakt. It's completely changing how we think about making music with code, basically bridging that huge gap between a composer's idea and actually bringing it to life. And that brings us to this big question. I mean, really think about it. Can a bunch of code, just lines of logic and algorithms, actually compose a symphony? Can it create something that's complex, beautiful, and expressive? Well, that's what we're here to find out.
So, to really get why a tool like Pytakt is such a big deal, we first need to understand the fundamental problem it was built to solve. For a long time now, if you wanted to create music digitally, you were kind of stuck between a rock and a hard place.
Okay, so on one side, you've got your digital audio workstations, or DAWs. They're awesome, right? Super visual, you can click and drag and see everything laid out, but they can be pretty rigid. Try to get them to generate complex music algorithmically, and you'll hit a wall pretty fast. Then on the other side, you have coding libraries. Now, these are incredibly powerful, no doubt, but it often feels like you're trying to build a car from 1,000 different boxes of parts. You need one tool for MIDI, another for musical analysis, maybe a third for real-time stuff, and the learning curve is just brutal. And this is exactly where Pytakt steps in. It's designed to be that elegant, all-in-one solution to this problem that creators have been wrestling with for years. So, what is it exactly? The official definition is a Python library for the text-based description, algorithmic generation, and real-time processing of symbolic music. Whoa, okay, that's a mouthful. But the key words you want to grab onto are description, generation, and real-time. Pytakt rolls all of that functionality into one single cohesive toolkit. Honestly, the best way to think about it is as a Swiss Army knife for digital music. You can write out entire musical scores just using simple text. You can tell it to generate music for you with algorithms. You can process MIDI live as it's being played. You can analyze musical structures, manipulate entire scores with simple math-like symbols, and you can even see and hear what you're doing with a built-in piano roll that actually has playback. It's the whole shebang. Okay, so let's get into the good stuff. What are Pytakt's superpowers? What are the core features that make this library so uniquely powerful? First up is its use of something called music macro language, or MML, and this is just brilliant. It's a way to write music that feels less like heavy-duty coding and more like, well, like you're just typing an email. You use these short, intuitive text strings to create some really complex musical scores. And check this out. This is the perfect example of how simple it is. This one little line of code right here, MML L16CDEF, is all it takes to instantly create a musical score with 4/16 notes. C, D, E, and F. It's that direct. No fuss, no complex setup, just music. The next superpower is how you can handle entire sections of music. You can basically treat scores like numbers in a math equation. Use a plus sign and it'll play one score right after the other. Use an ampersand and it'll merge them to play at the same time. It makes arranging and building up a piece feel incredibly natural. Okay, superpower number 3 is really cool. Pytakt has these tools called effectors, which are essentially for transforming your music in powerful ways. And probably the most impressive one of them all is the product effector. Let me break down how this works, because it's kind of like magic. So you start with just a single note. That's step 1. Step 2, you apply the product effector and give it a musical pattern, like, say, a major chord. And then, just like that, step 3, that one single note instantly blossoms into a full chord. You could do the same thing to create a fast trill or a beautiful flowing arpeggio, all from one simple command. It's amazing. So we've seen the superpowers, but what can you actually do with all this? Let's look at some real-world applications, because this is where it all comes together in some really fascinating ways. First up, procedural generation. Pytakt is an absolute beast at this. For example, you could easily recreate a minimalist masterpiece like Steve Reich's clapping music. You know, the one where a simple rhythm pattern is shifted against itself over and over to create this incredibly complex texture. Trying to program that from scratch can be a real headache, but with Pytakt's simple operators, it becomes almost laughably easy. Pytakt also acts as this perfect bridge to the world of AI. The workflow is just fascinating. You start with a musical score that's, well, it's computer perfect, totally robotic. Then Pytakt can convert that score into an image, like a picture of a piano roll. You feed that image to a neural network, and the AI analyzes it to figure out how a human would play it, with all those subtle changes in timing and volume. And then the magic part. Pytakt takes those human-like nuances and applies them right back to the original score, making it sound alive. And it's not just for creating music, it's an incredible analysis tool. Pytakt can basically act like a musical detective, analyzing a composer's work to find their unique fingerprint. Just look at this chart here, comparing the harmonic intervals of Bach and Debussy. You can instantly see Bach's heavy reliance on certain intervals. It's his signature style, quantified and visualized right there in the data. It's amazing. So we've seen what it can do, but what really sets it apart from all the other tools out there? Well, it all boils down to a powerful combination of speed and flexibility. If you just look at this comparison with other big libraries like Music 21 and Pretty_MIDI, the advantages become really clear. Pytakt is the only one here that checks all the boxes. Real-time MIDI I/O? Check. Simple text-based composing? Check. Easy score manipulation? Yep. And a visual piano roll with playback? Pytakt's the only one that brings all of that together in one package. But there's another huge difference hiding under the hood. Pytakt uses a brand new, super efficient algorithm for a really critical task, finding all the active notes at any single point in time in a complex piece of music. It sounds simple, but it can be a major computational bottleneck. And the result of that new algorithm? This number. 103 times. For that specific analysis task, Pytakt's setup can be up to 103 times faster than a major library like Music 21. That's a massive performance gain. It's a total game changer, especially when you're working with big, complicated pieces. So when you combine this incredible ease of use, all this power, and that mind-blowing speed, you really start to get a sense of where the future of music creation is heading. And you know, the creators of the library, Nishimura and Marui, they summed it up perfectly. They said Pytakt paves the way for using Python in interactive music applications, from algorithmic composition to automatic accompaniment. The key word there is interactive. So the big takeaway is this. By bringing all these powerful tools for composing, analyzing, and real-time interaction into one elegant package, Pytakt is tearing down the wall between having a musical idea and actually executing it. It's opening up a whole new playground for composers, for researchers, for artists, for everyone. And that leaves us with one final provocative question to ponder. What happens when composing music becomes as fluid, as direct, and as easy as just writing a sentence? What kind of creativity does that unlock? The possibilities are truly exciting to think about.